This video explores Project Orion, an audacious, tested, and ultimately forbidden plan. It was the key to exploring the planets by riding nuclear explosions into space, a chapter of space exploration history we chose not to use. Rocket technology faces the tyranny of the rocket equation. To accelerate, you need more fuel, but more fuel adds mass, requiring even more fuel to lift it. This vicious cycle demanded a completely new energy source. The theory was to harness nuclear power by placing a vehicle directly in a fireball. 1950s tests showed that a graphite-coated steel sphere could survive a 20-kiloton blast and be propelled by the expanding gas. Project Orion would have created a 4,000-ton interplanetary battleship. A single launch could have delivered 1,115 tons to low Earth orbit, or 300 tons to Mars and back without refueling. It was a massive step ahead of its time. Orion's design used 4 interconnected engineering solutions to turn repeated nuclear detonations into sustained thrust. This involved pulse units, a pusher plate, a suspension system, and a magazine and delivery system. Pillar 1 is the nuclear pulse unit. It uses miniaturized fission and a shaped charge to direct the explosion. The tungsten propellant absorbs X-rays and radiation, exploding outward as high-velocity gas. Its exhaust velocity is 10 times that of a chemical rocket. Pillars 2 and 3 involve the pusher plate and suspension system. The pusher plate absorbs the initial blast. The 2-stage shock absorption system, including a gas bag and hydraulic pistons, delayed and averaged the initial intense pulses into a sustained, manageable shove. Pillar 4 is the magazine mechanism, which stores and fires the pulse units 1 per second through the pusher plate. The inherent flaw, however, was that a Mars mission required 1,500 pulse units, making the project radioactive from a political and bureaucratic perspective. The world was not ready for Orion. In 1959, NASA cut funding, prioritizing chemical rockets. The project pivoted to the Department of Defense, who saw its immense payload capacity as a military threat to the established path of space exploration. Military concepts included an emergency command and control Orion and the Doomsday Orion, capable of orbiting a massive thermonuclear weapon. The military version was reportedly presented to President Kennedy, who rejected it as horrifying and unnecessary. The 1963 Partial Nuclear Test Ban Treaty explicitly forbade nuclear detonations in the atmosphere, underwater, and in outer space. Although Orion's pulse units were not technically weapons, the project was canceled in 1965. The dream lives on in culture, influencing science fiction like the work of Arthur C. Clarke and Stanley Kubrick. In engineering, modern concepts involve vacuum-only launches, orbital assembly, and advanced materials for future nuclear pulse vehicles. One proposed reimagining is the Mini-Mag Orion engine. It uses microfission and a magnetic nozzle to redirect the plasma, efficiently accelerating the spacecraft. A theoretical Mini-Mag Orion could achieve 1 gram acceleration with high exhaust velocity. Today, we face a paradox, a solution without a problem. Missions like a trip to Jupiter are not planned due to current rocket limitations. Yet, the technology like Orion, which makes them possible, lacks funding without a formal mission requirement. A new geopolitical contest or breakthroughs in fusion research could trigger Orion's revival. The history of Project Orion shows the boundary between bold scientific ideas and public controversy can be razor thin. This massive leap forward is still waiting to happen.